Ever wished you had an AI assistant that could, like, instantly pull up exactly what you need from a mountain of documents? No more scrolling forever or trying to figure out the right keywords, just straight to the answer.
Oh, yeah.
Well, today we're diving into something that's getting us closer to that, and it's called chunking.
It's kind of a hidden hero, you know? Chunking, it's super important for AI, especially when we're dealing with tons of text.
Absolutely. And get this, the way you chunk things can really change how well these AI systems actually work.
Yeah, some of the findings are pretty surprising.
We'll be using this research report from Chroma, a company that's doing some really innovative stuff in this field. They're really pushing the boundaries.
Yeah, they've done some really great work, especially when it comes to showing us, the problems with how we usually test these systems.
So before we jump into all the details, can you give us like a quick explanation of what chunking is and why it matters so much for AI?
Sure, so even the most advanced AI models, even with these huge context windows they're working with, right? They do their best work when they're given the most relevant information. Chunking, that's all about breaking down these big documents into smaller, easier to manage pieces.
So instead of giving the AI a whole encyclopedia, we're giving it like organized chapters, each one focused on a specific topic.
Exactly. Imagine you're looking for a specific recipe in a giant cookbook. It's going to take you forever if you got to go page by page. But what if it's organized? Appetizers, main courses, desserts, you go right to what you need.
Okay, that makes total sense. But the report mentioned problems with traditional benchmarks. What's the issue there?
Well, you've got these benchmarks like MTB, Massive Text Embedding Benchmark, and they mostly focus on whether the AI found the right document, but they don't really look at how efficiently the AI found the important stuff inside that document. And that's what really matters for real-world use.
Right, because in the real world, you don't want the whole document. You want the specific answer. Just like when you search online. You're not looking for whole websites. You want that specific answer to your question.
Precisely. And that's where Chroma's approach is really different. They went and made a whole new data set with queries and the exact parts that are relevant from a bunch of sources, the State of the Union address, Wikipedia, chat logs, you name it, even financial reports, scientific papers.
Wow, they really covered a lot of ground. So how did they test these different ways of chunking?
So they took a bunch of different algorithms, each one having its own way of dividing text into these meaningful chunks.
Okay, let's get into those algorithms. Which ones did they look at?
They started with some of the common ones, like the recursive character text splitter and the token text splitter. Those are pretty straightforward. They use punctuation and fixed length.
So they're not really understanding the text, just kind of dividing it up based on basic rules.
Right, like dividing a book into chapters just by the number of pages, not by what each section is about. It's okay for simple stuff, but not great for more complex data.
Makes sense. What about the fancier methods?
Well, they also looked at this one called the Kamrat Semantic Chunker. It's a little more, it analyzes the text and actually looks for shifts in meaning.
Like sensing a change in the topic.
Exactly. It tries to figure out where one thought ends and another one begins.
Wow.
So the chunks are based on those shifts in meaning.
That's pretty cool. But I imagine there must be challenges with that approach too.
Oh, for sure. Like the original algorithm, it didn't let you directly control how big the chunks were. They actually had to tweak it a little to give people more flexibility.
I can see why that's important. You wouldn't want chunks that are way too big or way too small for the AI.
Exactly. And then you have the cluster semantic chunker. It uses this really cool technique. It's called embeddings. So basically, embeddings are like numerical fingerprints for words and phrases. This algorithm uses those fingerprints to group together similar pieces of text, so you get chunks that are really coherent.
It's like solving a puzzle where the pieces fit together based on what they mean, not just how they look.
Exactly. And then they wanted to see what would happen if they used an LLM, a large language model, like the ones behind ChatGPT, to chunk the text. So they called this one the LLM Semantic Chunker.
Wow, an AI doing the chunking for another AI. That's pretty wild.
Right. And you know what? It actually worked pretty well. It might not have been the best in every case, but it definitely showed some potential.
So we've got a good grasp of the different methods. What did Chroma actually learn after testing all these chunking algorithms?
Well, the big takeaway is that how you choose to chunk, it really, really matters. It can completely change how well your AI does at finding the right information.
I bet that wasn't a huge surprise after what we've talked about.
True, but here's where it gets interesting. Remember we talked about those default settings that OpenAI assistants use 800 token chunks, 400 token overlap.
Yeah, that seems pretty standard.
You would think so, but Chroma's evaluation showed that it didn't perform that well. It actually scored pretty low in terms of efficiency, meaning it was bringing in a lot of irrelevant information.
So even the systems we're using all the time, they might have room for improvement when it comes to this chunking stuff.
Exactly. And that's why this research is so valuable. It's showing us where we can make even the most advanced AI even smarter and more efficient.
So if the default settings aren't ideal, what were some of the methods that did really well?
A few stood out. That modified Camrat semantic chunker, the one where they gave people more control over the chunk size, it did pretty well across different types of data. The cluster semantic chunker, especially when using smaller chunk sizes to get the details, that also showed a lot of promise. Oh, and we can't forget that LLM semantic chunker, the fact that it worked as well as it did, that really shows you the potential of these LLMs in this area.
It sounds like there's no perfect answer, huh? The best way to chunk depends on what you need the AI to do and the type of data you're working with.
Exactly. And that brings us to one of the coolest things about Chroma's research, the idea that there's like a sweet spot for chunk size.
Oh, tell me more about that.
Well, you see, if the chunks are too big, they might have too much extra information, making it hard for the AI to find what's important. But if they're too small, they might not have enough context, which could mess up the results.
It's like the Goldilocks thing, not too big, not too small, but just right.
Exactly. Finding that balance is going to be super important as we build and refine these AI systems.
So it's not just about picking the coolest algorithm. It's about understanding all the nuances of this chunking stuff and how it interacts with your specific data and what you want the AI to do.
You got it. This is a field that's changing all the time, and we're just scratching the surface of what's possible.
That's really exciting. This has been an amazing look into the world of chunking, and it's clear that it's not just some minor detail, it has a huge impact on how AI uses information. But before we go too far, where should our listeners go if they want to learn more about putting these awesome AI and LLM solutions into their businesses?
If you're looking to leverage this kind of technology, you should definitely check out Shogini Systems. Their website is https://www.shogini.com, https://www.shogini.com. They're doing some really cool things in the space.
Great. We'll make sure to put that link in the show notes too. But we're not done yet. In part 2, we're going to dive into some real-world examples from Chroma's research. So stay tuned.
So welcome back to our deep dive into all things chunking. We've talked about why it's so important, and we've gone through all these different ways to chunk text. But now let's actually see how they work in the real world, using those examples from Chroma's research.
Yeah, it's one thing to talk about algorithms, but I'm really curious to see how these chunking strategies actually work when you apply them to, like, real data, different types of data.
Absolutely. Let's start with something that's pretty well structured, like the 2024 State of the Union address. That kind of text, it usually has clear paragraphs, nice transitions, it's pretty organized.
So not as messy as something like a chat log or a financial report.
Exactly. And because of that structure, Chroma found that some of the simpler chunking methods, like the recursive character text splitter and the token text splitter, they actually work pretty well.
Oh, interesting. So for that kind of text, you don't necessarily need to use the most complex algorithm.
Right. As long as you pick a good chunk size and handle overlap the right way, you can get pretty good results with those simpler methods. They can take advantage of the structure that's already there in the text.
Makes sense. But what about when you try those simple methods on something more unstructured, like those chat logs we were talking about?
Well, that's where it gets trickier. With chat logs, you've got all this back and forth, people changing topics quickly. Sometimes sentences aren't even complete. It's a totally different beast from a State of the Union address.
Definitely. It's like trying to solve a puzzle where the pieces are all jumbled up and don't always fit together.
That's a great way to put it. And in these cases, Chroma found that those semantic chunkers like Camrat and Cluster Semantic Chunker, they really shined. They're designed to handle those shifts in meaning, to figure out which parts of a conversation actually belong together.
Because they can look beyond just the way the text is laid out, right? They can actually understand what it means.
Exactly. Think about how you would naturally break up a conversation into chunks. You'd look for pauses, changes in subject, things that tell you the conversation is flowing in a new direction.
It's like we're naturally good at sensing the rhythm of a conversation, even if it jumps around a bit. And these semantic chunkers, they're trying to do the same thing.
Precisely. And that's why they're so good at handling messy data, like chat logs or even social media feeds.
Okay, so we've seen how different methods work with structured text like that State of the Union and unstructured stuff like chat logs. What about something like a financial report? It's structured, but it also has all this jargon, these complex ideas.
That's a great question. Financial reports, they're interesting because they have a clear structure with sections, headings, and tables, but the language itself can be pretty dense. Even humans can have a hard time understanding it.
So how did the different chunking methods handle that?
Well, Chroma found that the best strategies often used a combination of structure and meaning. You couldn't just rely on punctuation or fixed lengths. The algorithms needed to understand the words themselves to create meaningful chunks.
So it was like a hybrid approach, taking the best of both worlds.
Exactly. For example, that modified Cumrat semantic chunker, we talked about that one earlier, right? It combines sentence boundaries with those shifts in meaning. And that turned out to be really effective for financial data because it was able to pick up on both the structure of the document and those nuances in the language.
And what about the cluster semantic chunker? Did it do well?
It did pretty well too, especially when they used smaller chunk sizes. Remember, this one uses those numerical fingerprints, those embeddings, to group similar pieces of text together. And for financial reports, those smaller, more focused chunks, they could capture those little details and complex concepts that might get lost in bigger chunks.
So it sounds like finding the right balance between structure and meaning is key for complex data like that.
Absolutely. And this just goes to show how important it is to pick the right chunking strategy for the data you're working with. There's no one perfect solution. It's all about finding the right tool for the job.
That makes perfect sense. Now, what about that LLM semantic chunker, the one where they use AI to do the chunking? How did that perform across these different types of data?
Well, here's the interesting thing. It wasn't always the top performer, but it consistently got good results across all these different data types. From the State of the Union address to those messy chat logs, it held its own.
So it's like an all-rounder. Maybe not the best for every specific task, but pretty solid overall.
I like that analogy, and I think it shows you the potential these LLMs have in this area. As they get better and smarter, I bet we'll see them playing an even bigger role in chunking. Maybe they'll even be able to change their strategy as they're processing the text, adapting on the fly.
That would be amazing. It would be like having an AI that just automatically knows the best way to chunk a document no matter what kind of data it is.
Exactly. It's a really exciting idea, and I'm sure researchers are already working on it. But even with the methods we have now, Chroma's research shows that we can make AI retrieval systems way more efficient.
And that efficiency, it means faster and more accurate results, which is something we all want, right?
Absolutely. Whether you're building a chatbot, analyzing financial data, or looking up research papers, the way you chunk your text can make a huge difference. It's this little tweak that can have a big impact.
Wow, this deep dive has really shown me how important chunking is. It's not just a technical thing, it's a fundamental part of how AI interacts with information.
And as AI keeps getting better, I think chunking is going to become even more important. It's going to play a big role in shaping the future of these systems.
It's definitely a field to keep an eye on. I can't wait to see what they come up with next.
Me too. And as we figure out better ways to chunk information, we'll be able to unlock even more of AI's potential. We'll make these systems even more powerful and easier to use. It's going to be really exciting.
This has been a fantastic look at how different chunking methods actually work in the real world. And we've even touched on the potential for AI to do the chunking for us.
And we talked about how choosing the right method depends on the type of data you're dealing with and what you need the AI to do.
But our deep dive isn't over yet. In part 3, we're going to step back and look at the big picture. What does all this research tell us about the future of AI? So stay tuned for the final part of our exploration into the world of chunking. And we're back for the final part of our chunking deep dive. We've really dug into what chunking is, why it's important, and how different strategies can affect AI when it's trying to find information. But now, let's kind of zoom out, look at the bigger picture. What does Chroma's research tell us about AI in general and how we interact with all this information out there?
It's really interesting to me how chunking, something that seems so, technical, actually connects to these big questions about how we as humans think and learn.
So it's not just about AI, it's about how our brains work too.
Exactly. We're always getting hit with tons of information all day
Yeah.
long, right? And our brains have figured out amazing ways to filter through all that noise, to organize what's important and decide what to focus on.
It's like we have our own chunking system constantly running in the background to help us make sense of everything.
Exactly. And as we build these AI systems, systems that are getting better and better at working with information, we need to keep those brain processes in mind.
So are we basically trying to make AI think more like us?
In a way, yeah. We want AI to be able to recognize patterns, to understand what data means, and to pick out what's really important, just like we do.
That makes sense, but it also makes me wonder what happens when AI starts chunking information in ways we don't expect or even fully understand.
That's when it gets really interesting and, maybe a little tricky too. We've been talking about finding the right chunk size, but what if the AI starts making decisions about what to keep and what to throw away based on its own rules we didn't program into it?
Like that old saying, garbage in, garbage out, but way
Yeah.
more complicated, right? If the data we give the AI is bad or biased, and then the chunking process makes those problems worse, we could end up with AI systems that give us messed up results.
Exactly. And this becomes even more important as we start using AI for things like healthcare, finance, even the legal system.
So it's not just about making AI efficient, it's about making sure it's doing the right thing, making sure we can trust it to handle information the right way.
Absolutely. And that's why this research from Chroma is so valuable. It's not just about making algorithms better, it's about thinking about the big picture. How we design and train these systems so they're doing what we want them to do.
This deep dive has been a wild ride, hasn't it? We started with all the technical stuff about chunking, but we ended up talking about intelligence itself, how our brains work, and even the ethics of building AI that aligns with our values.
It's amazing how something like chunking text can lead to such big, important questions.
It really is, and for anyone listening who is as fascinated by the possibilities of AI and these LLM-based automations, I highly encourage you to explore the incredible work being done over at Sogini Systems.
Oh yeah, absolutely.
You can find them at https://www.sogini.com, https://www.sogini.com.
They're doing some really cutting-edge work in this field, and they really get the importance of responsible AI development.
And with that, our deep dive into the world of chunking comes to an end. We've covered a lot of ground today, from the nitty-gritty details to these broader questions about the future of AI.
We hope you found it as thought-provoking as we did.
We hope this exploration has sparked your curiosity and got you thinking differently about how we all interact with information, both with our own minds and through the increasingly sophisticated AI systems we create.
Thanks for joining us on this journey.
Until next time.